Hello world, hello friends. Today I just want to talk about the series of adventures and misadventures I had with uh, a brand of bulbs that I got a couple of months back. So what happened was there was a nice deal on and dual color temperature, warm and bright, and Wi-Fi controlled smart bulb, kind of Google and Alexa supporting bulbs. And there was no real need for it, but for the fun of it, I just ordered five, and I got it. And I just opened one and I took a look. Um, I went through a couple of articles and I found that this can be easily hackable. So I used tuya-convert, which actually uses the actual Wi-Fi pairing protocol uh, to do a man-in-the-middle kind of attack, and then flash whatever Tasmota or ESP Home or whatever your custom firmware to it. So I did that. I flashed, I think ESP Home or Tasmota on one of it, and I just packed it up, right? So I didn't even bother to open the rest four, and I packed it up, and I was pretty happy at that time. And then recently I tried opening another bulb to flash, and then I found that the to convert is not working anymore. The I was puzzled why one bulb worked and the second one is not working. So I opened each one of them. I found that three of them flashed very easily, no problem at all. But two of them is I marked them and kept it separately. So last week I took a look at it. I understood that this is not going to work, so I opened it. So, and another thing that I missed to notice when I bought it is that two of them got a separate packing. This is the original packing that which has some ESP8285 based module, which is easily to a convertible, and then on the left hand side we have the ones which are not really the same gene, which is not having the same gene, and as you can see it's an entirely different batch. um, so I didn't bother to open the ones that are good, ones which flashed without doing anything, just using tuya-convert and it's a flash. The other one has got double packing too. The first it's oh sorry, it has got an internal box. I think they didn't even they got one batch with a no packing, and just didn't even bother to take the bulb out. They just put the pack inside the pack and rebranded it. This one has very simple packing, meaning they are custom built um, for this particular manufacturer or brand or whatever. So anyway, that's the packing. Let's go to the actual bulb. So this is the bulb, right? So this got a little bit more translucent dome, a little bit bigger than the other one. Let me see if I can show you that. Yeah. So this is the one that worked easily. So you can see that this has got the branding in the bulb itself. I just marked which firmware I flashed. And this one has no branding. So what I think they did is they caught hold of some manufacturer, unbranded manufacturer, and because there was a lot of demand, they just asked them to not even brand it because there was no time. They just put it in a box and sell it. So anyway, so when I opened, what I saw is that this one has got 3 PCBs. One is the actual aluminum based bulb PCB, which has got its own LED controller and a non-isolated power supply, right? So a non-isolated power supply which just filters it and send the power supply directly to this board. That's 230 volt directly coming here. And then there is a auxiliary power supply which just generates, that's also non-isolated sadly, but doesn't matter, right? If it's a fully sealed bulb, okay, so that is sealed. And then that's the auxiliary power supply to supply 3 volt just to the control module, the Wi-Fi module. But in this particular, the 2 bulbs that I got, the auxiliary module is not ESP32 or ESP8266 or ESP8285 based, but it's another custom, it's another player in the block. It's by Beken, BQ72 some 723 or something, which is also hackable. But what I decided to do is I just had a couple of ESP12F modules. I just wired it up and flashed Tasmota in it, and then I just wired. So the wiring is pretty simple to this module, right? So you need the power, the 3.3 and ground, and then the cool white PWM and the warm white PWM. So the rest, the module is designed to have 5 signal and then the power. So I think they are using the same module for RGB and RGB warm white cool white model, as well as for just warm white cool white model. So this one is just warm white and cool white with no RGB. So they are not using the other 3 lines for red, green and blue. So anyway, so if you end up buying these kind of bulbs and you want to really flash firmware, this is what you have to do. You cannot use anything else other than ESP12F, because everything else other than the dome is aluminum or metal backed. So here we have fully metal lined plastic, and then this is metal, and the bulb itself and the top part, this is also fully aluminum metal. So the only way if you have to get decent Wi-Fi reception is to make sure that the antenna projects through this gap so that it can go through this plastic area. So for that, first you need to pop these connectors, and then so this is silicon lined dome. So you have to use something like a small unsharpened knife or something, insert through the gap for a couple of times and then try to pull it hard. This will come off, and then the next thing you have to do is you have to pop these out, so that so I will show you how to assemble this so you will understand what I'm saying. So I have soldered these wires. Let's put some tape. I don't have silicone glue right now, so it will be better to glue it using silicone glue, but yeah, that's what it is. So I'm not using any fancy stuff with this one, because I just wired the ESP826 module. I connected VCC to IO2 enable and ground to IO15. So I just used the bow wire and then just shorted the ground and the 15 IO-pin 15, and then to flash I just use the clips to flash RX to TX, and then ground the IO0. Once you have that, you can easily flash. Once it is flashed, then once it is flashed once, you can use the OTA to upgrade if you want. So just tape these things. And then also tape the top part. You don't need metal contact for the Wi-Fi. Taping it will work because of the aluminum. So now you can fold these wires, keep it. I'm not too bothered about this thing, because it's not going to have okay, you just poke it through like this. This is enough, meaning if you want you can tape that to the first of the part, so that even accidental sharp thing is not less chance, but still you can do like this. Just as a precaution, that's it. This is more than enough. And these are very cheap bulbs. And then line up with enough gap. Try the gap here. Should be enough. Now insert it. So line up like this first, and okay, make sure that both the wires come out here, and then make sure that you seat it well. So actually the heat transfer before opening it happened through the silicone glue. Most of them now it's just direct contact with not much, but that should be enough. Try to reduce the brightness if you want a little bit, so that it won't you don't drive it to the max. Insert back these contact pins. That's it. So now we can test. Let me see. um, hmm, why it's not working? Okay, let me check. Okay. Ah, it is working. So the brightness was low. Okay. Let me show you guys. Um, where is the cable? Okay. So as you can see, yeah. Because if you dim little bit, it's the yeah, at least you need this much brightness. That's why it was not working before. I kept the brightness too low and it has trouble starting up, especially in the blue area, I think. Now it is working. I don't know because yeah, that's the only thing. At the low, okay. So this is working pretty nicely. Oh, too bright. Okay. So yeah, I am not bothered to put silicon glue, but yeah, once it is there, if you are not doing mountain biking or anything which shakes it too much, and this should be all right. And we have tape with the insulation grade cello tape anyway. Yeah, so that's it, guys. So if you got this this non-ESP based smart bulb and you are not happy, you can use this method to install Tasmota or ESP Home or any other firmware, ES Purna or whatever. And also this particular chip, right? So if you have a Beken based BK7523 based chip that you extract from this bulb, this is also pretty easily hackable. So the Tuya SDK can be used to develop open firmware. There's already a open BK something firmware. Okay, let me see. So it's not easy. It's not that easy to solder wires from this module because the RxTX and all is small test pads. But once you solder it, it's very easy to flash and very easy to get the logs and everything. It's a ARM based SoC Beken BK7523, I think. Ah, 7231, yes, this is the one. Beken alias STK, Beken free RTOS, Beken. One thing, there is something called OpenBK or something. It's a pretty nice SoC, meaning. OpenBK7231. So anyway, so yeah, so you can get another dev board to play with, and then you can be happy with your Wi-Fi bulb. What did I do? What did I do? What did I do? What did I do? That's not the bulb. It's 140. Boom, boom, boom. Yes. Here we go, guys. Thanks a lot for watching. I'll post more content like this if I find it interesting. So yeah, that's it. So have a nice one. See you in another video. Thank you. Bye.